Hello everyone, I'm Jivika Kancharla and I'll be explaining you guys the solving of the first question in homework 5 of the course Probability and Stochastic Processes. So let's have a look at the question. Given x and y are independent with the probability density function of x is equal to u of x minus 1 minus u of x minus 2 and the probability density function of y is equal to u of y minus u of y minus 1. Also z is equal to x plus y. We're supposed to find the probability density function of z. And for this we will be using two methods, that is the convolution method and the geometric method. That is the in convolution method we will be using the probability density function for z will be equal to this formula. Therefore let's have a look at the solving. Given x and y are independent, the probability density function of x is equal to u of x minus 1 minus u of x minus 2. The probability density function of y is equal to u of y minus u of y minus 1 and z is equal to x plus y. If we look at these two equations, we know that they are box functions. So let's go to the part 1, that is we are finding the probability density function of z by using the convolution method. Therefore, since we know these first two steps are from the formula only, therefore when substituting the probability density function of alpha given x will be equal to u of alpha minus 1 minus u of alpha minus 2, and similarly for 2 minus alpha will be equal to u of 2 minus alpha minus u of 2 minus alpha minus 1 over the integral from minus infinity to infinity. Therefore, if we just separate these terms, we will be getting from minus infinity to infinity u of alpha minus 1 into u of z minus alpha d alpha minus integral of minus infinity to infinity u of alpha minus 1 into u of z minus alpha minus 1 d alpha minus integral minus infinity to infinity u of alpha minus 2 into u into z minus alpha d alpha plus integral minus infinity to infinity u of alpha minus 2 into u of z minus alpha minus 1 d alpha. Therefore, if we do the integration and solve this, we will be getting the equation as z minus 1 u into u of z minus 1 minus 2 into z minus 2 into u of z minus 2 plus z minus 3 into u of z minus 3. Therefore, this equation, in order to represent it, we'll be going through a series of graphs. Therefore, for the probability density function of z, we will be taking that on the y-axis, and on the x-axis we'll be taking the values of z. Therefore, at the value of z equal to 1, the line will be an incrementing line, and for similar in the case of when z is equal to 3, the line will be an increasing graph. And therefore this equation will be z minus 1 into u of z minus 1, and this will be z minus 3 into u of z minus 3, and this line equation will be z minus 2 into u of z minus 2. But this is not the graph that we want, since this is not the cumulative equation that we want. We want the equation as this. Therefore we will try to do a little modifications, and then next we will be coming to this graph where we will see that the value will be increasing from 1 to 2, and once it reaches 2 it will start to decrease. Now this part line equation will be z minus 1 into u of z minus 1 minus z minus 2 into u of z minus 2 minus z minus 2 into u of z minus 2. But this is, however, still not the equation that we want. Now let's check if it will be valid if again from 3 if the value is increasing. But this is also not the equation. Therefore we will stop it at z is equal to 3 and make sure that it will not go beyond. Therefore this will be the graph. From 1 to 2 it will increase, and from 2 to 3 it will decrease. Therefore the probability density function for z is equal to z minus 1 into u of z minus 1 minus 2 into z minus 2 into u of z minus 2 plus z minus 3 into u of z minus 3. Now going to the second method, which is the geometric method. Once again, let's go through the given parameters, that is z is equal to x plus y. The probability distribution function of x is equal to u of x minus u of x minus y, and the probability density function of y is equal to u of y minus u of y minus 1. Now this will be, we'll be taking 3 cases, and the first interval will be z is between less than or equal to 1. That is, let's take this square where of 1 by 1 square. Now since if the value of z is less than 1, that is you can see this. Now for the probability distribution function for z will be equal to probability of x plus y less than or equal to z. Now this will be p of x plus y is less than or equal to z will be the area of this graph. Therefore the area of this will be half base into height, where the base is z and the height is z, so it will be z squared by 2. Now since this is the probability distribution function, the density function will be equal to d by dz of the distribution function. Therefore when we do this, we'll be getting that the probability density function will be equal to z for z less than or equal to 1. Now let us take the second interval, that is z is between 1 and 2, and therefore again there's the square, and we have z and z here. Now we're supposed to find the area of the shaded part. Now the area of the shaded part will be equal to area of this triangle minus this and this triangle. Therefore the probability distribution function will be equal to the area of that triangle minus this triangles. We will be getting the value of 2z minus 1 minus z squared by 2. Therefore once again the probability density function will be equal to differentiating the probability distribution function. Therefore if we do that, we will be getting the value is equal to 2 minus z. Now the third condition will be when z is greater than 2. We know that the probability distribution function will be equal to 1 for the conditions where z greater than 2, and therefore the probability density function will be equal to 0. Now since we've did a shift left, we will now do a shift right. Therefore this will be equal to 1. At 1 it will be increasing, at 2, and from 2 to 3 it will be a decreasing graph. Therefore this is the probability density function for z.